Welcome to The Explainer. Today, we're breaking down a major GPU showdown that is, well, absolutely crucial if you're working on AI projects. We're talking about the powerhouse RTX 3090 Ti versus the very modern RTX 4070 Ti. So let's just dive right in. Look, we're not just comparing two graphics cards here. We are comparing two absolute titans that represent completely different ways of thinking about performance. You've got raw, overwhelming power on one side and smart, architectural efficiency on the other. So which is better? All right, let's meet our fighters. In one corner, we have the reigning champion from the last generation, a card that's really just known for its sheer muscle. And in the other corner, a newer, more sophisticated challenger, really built for the modern era of AI. And this right here is the core of our story today. This isn't just about specs on a sheet. It's a genuine clash between two fundamentally different ways to accelerate artificial intelligence. The 3090 Ti, it's all about brute force, with a massive memory pool. The 4070 Ti, though, it's the efficiency expert. Okay, first things first, let's break down the raw numbers. Looking at the tail of the tape is really the best way to see where each card's strengths and, weaknesses start to show up. Now, what's so fascinating about this slide is the story it tells. Just look at those huge divides: memory size, memory bandwidth, L2 cache, and power. The 3090 Ti just completely dominates in memory, right? But then the 4070 Ti has this massive cache and draws way, way less power. This right here sets the stage for everything that follows. Let's start with the 3090 Ti's biggest, most obvious advantage. It has a massive 24GB VRAM pool. That is double what the 4070 Ti has. And let me tell you, for training large models or working with super high-resolution data, this is an undeniable, absolutely game-changing amount of memory. And it's not just the amount of memory, it's how fast you can get to it. At over 1,000 gigabytes per second, the 3090 Ti's memory bandwidth is like a giant 10-lane superhighway for data. It just lets it feed its core at an incredible rate. And for memory-bound tasks, that is absolutely crucial. But here's the trade-off. All that power comes at a cost. The 3090 Ti consumes a massive 450 watts. This is exactly where the 4070 Ti's modern design really shines, using significantly less power. And what does that mean for you? Well, it means less heat, lower electricity bills, and, frankly, an easier time integrating it into your system. So, you might be wondering, how in the world does the 4070 Ti compensate for having half the memory and half the bandwidth? Well, the answer is pretty cool. It lies in some very clever architectural tricks that really define this newer Ada Lovelace generation. So, just to recap, think of memory bandwidth as that wide highway we talked about. The 3090 Ti has a super highway, built for the most massive amounts of traffic you can possibly imagine, like trying to load up a huge AI model all at once. And this just perfectly illustrates the 4070 Ti's strategy. Instead of that giant highway, it has a massive L2 cache right on the chip. It's like having a personal toolkit, keeping all the most essential data right there next to the processor so it doesn't have to make that long trip out to the main VRAM. This just slashes latency and boosts efficiency. It's really clever. So the crucial point here is that this represents a major design shift. We're moving from a philosophy of pure brute force, just build a wider memory bus, to a philosophy of smart, efficient data handling. Basically, it's about working smarter, not just harder. And the 4070 Ti brings another weapon to this fight, its next-gen tensor cores. Now, these don't just improve performance for standard data types. They also introduce native support for FP8. So, what's that? It's an 8-bit floating point format. It's basically a way of representing numbers that uses way less memory, which promises some incredibly efficient AI inference down the line. So, all that theory is great, but how do these different philosophies perform when the rubber meets the road? Let's take a look at how they stack up in actual AI workloads, everything from image generation to fine-tuning models. When it comes to fine-tuning large models, that extra VRAM on the 3090 Ti is an absolute game changer. As experts have pointed out, it lets you work with massive models. We're talking up to 36 billion parameters without hitting those dreaded memory walls. That's just something the 4070 Ti simply can't do. So it really boils down to your specific task. If your job is memory heavy, things like fine-tuning or generating massive high-res images, the 3090 Ti is your champion, no question. But if you're focused on efficient inference or deploying models where power and heat really matter, the 4070 Ti has the definite edge. Let's take Stable Diffusion as a super practical example. At standard resolutions, the 4070 Ti really hangs tough, performing very, very close to the 3090 Ti. But the moment you start cranking up that resolution, generating those massive, high-detail images, the memory usage just skyrockets past 12 gigabytes. That's the moment the 3090 Ti pulls away, avoiding all the performance hits or out-of-memory errors its smaller sibling would face. Okay, this brings us to our final section and the big verdict. And as you've probably figured out by now, there's no single winner here. There's only the right tool for your specific job, for your specific fight. Your decision really just boils down to this simple framework. First, ask yourself, is my work limited by VRAM? If the answer is yes, the 3090 Ti is the clear choice. Simple as that. Second, is efficiency your top priority? If you're focused on deployment or power costs, then yeah, the 4070 Ti is the way to go. And finally, think about the future. That FP8 support on the 4070 Ti, that could become a major advantage as software continues to evolve. We've covered the high-level battle here, but if you want to get into the weeds with really detailed benchmarks and more in-depth comparisons, we highly recommend you check out the full article over at bestgpusforai.com. We've put the link for you in the description below. And that leaves us with a final thought to chew on. This whole battle between the 3090 Ti and the 4070 Ti, this clash of brute force and smart brains, it isn't just about two products. It's really a preview of the ongoing evolution of hardware design for AI. So, which philosophy do you think is going to win out in the long run?